Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source, containers, and infrastructure as code. To learn more, visit snyk.io/TSD. That's SNYK.io/TSD.
The most common workflow is running against your attack surface. So in an organization, you might have a pretty large set of assets, and these could be varieties of applications or APIs running in your environments. So you basically give your list of assets. These could be IPs, these could be domains, and or API endpoints that you want to run against, and you pass it to Nuclei and give your templates that you have designed and run against them.
Hello and welcome to another session of The Secure Developer. My name is Simon Maple and I'll be the host for this session, which brings along Rishi Sharma. And Rishi is the CEO and co-founder of Projectdiscovery. Welcome, Rishi.
Yeah, thanks for having me. Really appreciate for inviting.
That's absolute pleasure. Absolute pleasure. Now, Rishi, why don't we start with a little bit of background into you personally? Tell us a little bit about how you got into the security space and what steps you took to join us.
Sure. My career started at bug bounties in 2012, 2013. It was before the era of HackerOne and bug crowd platforms. I used to hunt on these traditional programs like Facebook, Google, and that's where my journey got started. And probably did it for 2 years full time. And then for the rest of my career, I mostly spent the time working as pen testers, cybersecurity engineer, application security engineer. I also took the job of product managers in between and also worked as product designer in between, mostly for startups and tech companies. But yeah, before Projectdiscovery, I mostly worked as application security engineer.
Wow. So you had a variety of roles before moving into the security space then?
Yeah, always been fascinated around products. So that's why I co-founded few small startups as well as worked with startups. So I spent majority of my career working with startups just to gain the momentum of building products, how the products are being shipped, etc. But yeah, love the overall journey throughout these years.
Excellent. Well, that's great to hear. And today we're actually going to be talking about a specific technology. And in fact, one of the areas in which one of the open source projects that you co-founded and created called Nuclei. And this really brings together some of the developer security aspects of the shift that we've seen over the number of years, but with an area of security that traditionally is probably even the furthest away from the left in and around the kind of like pen testing space and even into the DAST space. So we're going to have we don't normally talk about technologies and products so much, but we're going to make a slight exception here simply because this is a very, very interesting space. And also there's a big open source component to this. Now, Rishi, you talked a little bit about Projectdiscovery there. Tell us a little bit about what the company is, how the company works, how it drives so much open source contributions.
Sure. We are an open source cybersecurity company. We basically develop varieties of open source tools for security engineering. Two of our top categories of tools are, one is asset discovery tools. So we have designed a range of tools for different personas within the security teams for them to easily track the deployments happening across the organizations. And the second set of tools are vulnerability assessment tools. Basically, once you have the data around your assets, how do you do the vulnerability assessment on top of them? Or how do you find security vulnerabilities within those? So those are the two kind of categories we have. Although we do have other kind of tools, but these are the top categories. Our approach on the product is like all the co-founders came from security engineering world. If you know, like products in our cybersecurity are too complex. These are siloed tools. You can't easily collaborate with the teams. And that was some of the fundamentals we kind of designed on building these tools. So these tools are really highly programmable, customizable, really simple to use, and easily integratable across your different workflows. So you can collaborate with different team members And we then built it on top of open source to make sure that it drives through the community, not through the vendor-driven approach. Yeah, these are some of the core essential part of our tools.
And it's very interesting then when you talk about collaboration, because of course, when we try and shift left and when we try and put tools in developers' hands, that collaboration between the development or the security or who was traditionally owning the security tools, that collaboration across back to the development organization has always been one of the biggest sticking points or one of the biggest problems to the adoption of developers taking on this kind of new processes or ownership. If we're looking at Nuclei specifically, and we'll talk about that in just a sec, but the problems that Nuclei is kind of trying to address, I guess, stem from the DAST and pen testing space. Talk us through the problems that you see in that area right now and why it's hard for organizations to shift that kind of testing further left and trying to put those tools into developers' hands.
There are many reasons. One, first, if you closely see the cybersecurity industry, we have a range of dozens of different security scanners or tools that you have to manage within the workflows. So that mess of different tools is one key area of security engineering. And then these tools are designed in a way that you can't easily attach within your modern workflows. These are like really siloed, complex tools that can only run by a specific security engineer and can't easily attach within the different workflows. There are many key reasons. One is these are closed source products, and you don't really have the programmability or access on doing or programming as per your organizations. So you lose that momentum on designing and customizing your workflows based on organizations. So Nuclei, in the context, we kind of like put the focus in a way where we create a framework where all the different kind of attack vectors can be automated. So whether it's a task, fudging, or your different kind of attack vectors can easily be programmed. And we are continuously growing within those supportive protocols or supportive workflows. And then the piece of template or the programmability, once you compose a template, you can then use it consistently or easily across your different pipelines. So giving that power to the security engineer or different team members within that workflow allow teams to easily minimize the vulnerability lifecycle of your different workflows.
And so it sounds almost like a DAST as code or a pen testing as code way of doing things, kind of looking at it from the Nessus and map of old kind of style of how we update that in terms of bringing it back to code that is shareable and that is contributable, right?
Yes. And we used these traditional tools in our entire career. And that was one of the key inception that why these tools don't work. And when we really spent the time on these key workflows, we kind of like thought, okay, we need first a really collaborative nature of tools that can easily attach within workflows. And then giving these powers to the end security engineers would allow a flourish mechanism to push different kind of attack vectors or easily let security engineers design their workflows. And yeah, we kind of like really got inspired from Terraform initially. So we even called it this whole phenomenon, like it is like Terraform, but for vulnerabilities. You compose different vulnerabilities within a template, and then you kind of plug it within your different pipelines and basically run across your different teams or workflows.
So tell us a little bit about the origin story of Nuclei and how was it created? What were was it a number of projects that kind of like came in and created this, or did it come from a problem that you were experiencing? Was it requests coming in from the community? How was the concepts thought about?
I can give a bit of insight on how Projectdiscovery started, and then like this whole story was like really attached to the Nuclei. So we all co-founders were like really active on open source community. So I was using one open source tool in my company, in my previous company, and basically I found one of the top contributors of the same repo that I was using the tool for, and he then introduced me to other top 2 contributors of the same repo. And because we all were security engineers and we had decent software engineering experience, we thought, let's dive into some of the core problems. And these problems were like very similar to mine. Like these tools we have to manage like loads of different tools. These are really complex to manage. These are siloed tools, don't have collaborative nature. So we kind of started with that inception. So for the next 6 or 8 months, we didn't know our names. We just got connected on GitHub. We used to communicate with usernames. And probably after 6 or 8 months, we became really good friends. And that was the inception of Project Discovery, where we picked this username on GitHub called Project Discovery. Never thought PD would ever be a company. We kind of like started just to build the tools for ourselves. So we started putting out tools on the open source, started seeing a decent or maybe like some couple of GitHub stars on our projects. And that gave us enough motivation to continue doing it. And within that framework, we had this idea of Nuclei. So we put that repo. If you go back to our commit history, Nuclei looks very basic initially. When we released it, it was very, very basic. But community really pushed because of open source. We got really amazing ideas. We had only one protocol supported, and now we have like 7 or 8 protocols supported. So community pushed on different features, different workflows we needed to support. So to be honest, like we never thought Nuclei would actually push in the way that it is now, got only possible because of our open source community.
Yeah, well, it's an amazing story, and it's always great to hear those success stories that are built from the community and from developers who are, obviously finding the project and the technology useful and useful enough to be able to contribute back to, which is always a wonderful success story. And of course, this isn't just an open source project. There's a commercial aspect to this as well, right?
Yes. Entire goal was to first build the community when we went full time. So in 2021, we raised a small round, went full time into Project Discovery. But our entire goal was to build the community because, like we don't really have culture of open source and communities in cybersecurity. So our entire goal was to whether we can really have a community, like really an active community who uses the tools, who contributes back or not. And yeah, we always had the plan that eventually, once we see that there's a community forestation happening, we will start working or approaching on how to commercialize it. We are pretty early in our stages, but our approach is very similar to like how other open source companies did it, like how HashiCorp and other companies did it.
So let's go a little bit deeper then. And you mentioned kind of like Nucleus using the Terraform style of working. Tell us a little bit more about that and how people would actually contribute and use those kind of things, because it's essentially pulling what we would consider a more black box kind of work or more manual work into code. So tell us a little bit more about how that gets done.
Yeah, similar to like how Terraform has the concept of Terraform templates, we have the concept of Nuclei templates. In each Nuclei template, you can put all the essential information or all the data around vulnerability lifecycle of a vulnerability. So you put the data around what is the vulnerability about, description, you put the data around remediation, you put out the data around prioritization, classification, severity data. And the fourth key part of the template is the validation of the vulnerability. And it is essentially what a human would do to verify the vulnerability. And you describe that vulnerability step by step, that you go onto this endpoint, you perform this action, you do this, and you compose that into a template. And this is basically a basic structure of a template. And we support a range of different protocols. So you can basically write almost all kind of vulnerabilities within Nuclei, and then you can use it to scan against your assets data or scan within your CI/CD workflows, or you can use the same template to do the lifecycle management of vulnerabilities. So triaging or creating tickets, remediation workflows, all can be done through the single template. So the collaboration becomes seamless through the data of template.
Very interesting. And it's a great segue actually into where would you then run Nuclei in terms of executing it in your pipeline, or is it more on the developers, or is it later to the right? What would be, I guess, the 3 primary use cases of using Nuclei?
The most common workflow is running against your attack surface. So in an organization, you might have pretty large set of assets, and these could be varieties of applications or APIs running in your environments. So you basically give your list of assets. These could be IPs, these could be domains, and or API endpoints that you want to run against, and you pass it to Nuclei and give your templates that you have designed and run against them. And it will do the assessment across those assets in the fast manner and give you the results back. The second one is CI/CD integrations, and Nuclei acts more like a regression tool. You basically put your templates within your CI/CD workflow, and you run against your local application or within your build workflow to ensure that vulnerabilities that you have put as regression are not passing through to the production. So that is the one use case. And even in that use case, like there are many bug bounty programs that are basically giving rewards or incentives on hackers submitting vulnerability along with template. So once they receive a template, they put that template into the CI/CD to ensure that it doesn't repeat again, as well as they use the same template or run against all their internal, external assets to ensure that there are no repetitions of vulnerabilities within other environments. These are top two workflows. And the second one is more around security engineering. So many pen testers or security engineers design their workflows to automate many of their regular workflows. So if you have suite of checks that you are running through the assessments or the pen test or audit, you design these checks and run against within any audit or your assessment project. And these are some of the top three workflows.
Yeah, very interesting. Do you find people who are working with bug bounties, so people who are actually trying to test against folks who run bug bounties, do you see them using Nuclei a lot for that kind of thing?
The bug bounty hunters, or you are talking about bug bounty programs?
The hunters.
Yes, they use a lot. And we have one of the large user base within the bug bounty too. And they use it mostly because they have their unique approaches on testing across large number of assets or large number of bug bounty programs to find the vulnerabilities faster. And their core approach is to like find vulnerabilities as fast as they can. And Nuclei helps them a lot. So basically, whatever their unique techniques that they use it against an application, they basically compose within the templates, and then they run it as if get access to any program or doing any assessment. They also do the verification of vulnerabilities against other hosts. So let's say they spot out a vulnerability, they will compose that vulnerability into a template, then they will immediately run against all the other assets they know about, and they will know, okay, this vulnerability also exists across other 10 hosts that they can report against, or these 5 other programs that they can report against. So bug bounty hunters use a lot within their workflow to test unique vulnerabilities.
And like you say, being able to supply that template afterwards is very, very valuable to the bug bounty program hosts.
Yes. Yeah.
Let's move into the CI/CD pipeline then. So you mentioned that was a good use case. Obviously, when there are reasons why DAST, traditional DAST pen testing isn't as well adopted in CI/CD, certainly not synchronously very often, because they can often be very long running. And then, particularly when we then, as we mentioned before, when you try and get that collaboration or communication with the development teams then very often, aren't necessarily as quick to fix as they can be very often, because it's not necessarily linked to code, or they don't necessarily have access to rerun testing to make sure things are fixed. How have you approached these types of problems?
So one of the core key problems of a traditional DAST is the time it requires to run the scan. This is, I would say, one of the key reasons that DAST really doesn't fit into the CI/CD or modern engineering workflow, that it requires a really good amount of time to complete. And the second piece is the noise or the false positives that DAST may produce because of the nature of finding unknown vulnerabilities. So Nuclei in this context works on known vulnerabilities. So you define the templates that you have already found a vulnerability around, and then you are running it in your CI/CD. So Nuclei, it won't really find vulnerabilities by its own. It will only run the scans based on the templates that you have provided. And these templates are mostly around the vulnerabilities that you have already discovered. And now you are using more like a regression engine within your CI/CD workflow. So the time it requires is pretty fast. So if you run Nuclei, even on a large set of data, it is very, very fast. That was one of the key focus of us on building Nuclei, that it works pretty seamlessly and it works pretty fast. And on the second part, the noise and the false positives, because Nuclei has this concept of validation data, and it is basically what a human would do to verify the vulnerability. And now you have composed that same step into the Nuclei template. And now when you are running or testing against application, the number of false positives are really, really low, because you have kind of designed based on your steps. And second, even if error or false positive occurs, you can go back to that template re-edit it and refresh the pipeline immediately. So now you have full control over false positives. These are one of the core problems within the traditional Dast.
Which is a great flow, actually, because you fix it for yourself, but you also fix it for the remainder of the community who are going to use that template as well.
Yes. Yeah.
Really interesting. So the approach, I do like the approach, and it's something we actually kind of use a little bit at Sneak sometimes as well, whereby in order to sometimes reduce the false positives, you need to consider the idea of allowing potentially some false negatives that get in by saying, look, we're only going to look at these vulnerabilities that come in that we know about, that are known vulnerabilities, for example, or that we have very, very high confidence over. But the benefit of that is you actually have something that you can have high trust on, that your development teams will have high trust on, and will actually be more likely to want to go ahead and remediate and have the ability to go to remediate versus, tens and tens of false positives or hundreds of false positives that just become very frustrating, and developers actually push away against that. So you're actually in a worse place by providing as much data as you possibly can versus very succinct and very trustworthy data.
Yes, and it's really important. It saves a ton of time both for security engineers as well as developers. Security engineers also waste a lot of time triaging the vulnerabilities discovered by scanners. If those alerts are being triggered within developers' pipelines, they also get frustrated because now they have spent the time to find that vulnerability actually doesn't exist. It was just false positive. So both within the world of security engineering as well as developers collaborating really saves a ton of time by having vulnerabilities upfront validated by the scanner.
Yeah. So we talked a little bit about Dast, and we talked about pen testing and other things. Fuzzing, another interesting space that we hadn't mentioned just yet. How does what we've talked about with Nuclei, how does that work in a world that already has Dast, fuzzing and pen testing? Is it designed to effectively work within that space where it's complementary to those tools? Or is this looking like potentially a replacement? Do you see companies replacing their existing solutions with this, or is it more complementary today?
It depends. We have seen many companies replacing their existing tools because mostly two core reasons, the speed and the false positives. I would say false positives were one of the core reasons that they have stopped using that tools because it's just been 2 years. The framework is still growing. We just dropped the fuzzing support just a month back. And we are now pushing our framework to support our known vulnerabilities. But we are very careful on making sure that it doesn't go into the same space where the tool is just producing tons of false positives. So there are still areas that we need to work in order to completely replace. But we have seen many companies just replacing with that traditional tools over Nuclei.
And I think one of the other areas there where we talk about Dast and pen testing is ownership. Talk about that in just a second, but I want to kind of hover around community just for one last piece, actually, because community is an area that needs nurturing. It's something which can sometimes build very organically, which it sounds like that's how it started in and around the Nuclei project. But let's talk a little bit about that, because Nuclei does have an unusually large community today, and that community does seem very keen to contribute and very engaged. Talk to us a little bit about what you do as an open source maintainer to nurture that community, to help that community. What are the key things that you feel the community needs to remain that engaged and remain that open to feeding back?
Yes. So I think when we started, to be honest, we never thought ever have this kind of community. But one thing we really, really spend a close time with our users for like shipping features as a request, or like having that one-on-one conversation with them every time they put out the feedback or they get at any enhancement or reports any bugs or any security features that they want to see. And I think it was really needed in our industry where products are generally closed source. They are not generally accessible. You can't easily program. So when we started, people really saw that benefit of having really open framework where they can collaborate. So when we started, we really put a consistent time on any requests that they were putting out, whether it be in the Twitter or GitHub or any other community. We generally saw people speaking around Nuclei. I would say like spending close time or building the relations were really, really important. And because we all co-founders came from open source community, we had that natural understanding of how to communicate, how to go after the users' relationship. So I think we did that in a really consistent manner. The second piece is education that we might not have done a lot of work, but we are still working on that area. Is what are the area, like just educating through the content or the new varieties of blogs, or just pushing out content, regular content on Discord or GitHub discussions. So people have a lot of ideas that they can go through or new pieces that they can start with. And that was really important for us too. And yeah, I think these were two. And then appreciating back, rewarding back users were also really important. Like once you see users contributing, you go reward them, appreciate them on your channels or your GitHub social channels, so they feel rewarded that they are part of the community, they are part of that the roadmap or the innovation cycle that we are pushing out the tools for. These were some of the core areas. I think the education on the content is something we need to do a bit more work, and something we have planned for 2023. I would say these were some of the core areas at how we catered the community.
Yeah, sounds very common in terms of the things that users want, right? They want to know, they want to see how others are doing things, they want that documentation about how to do things, and then that celebration of success is a core piece to actually almost like ignite the next steps from them personally, as well as others seeing that in the community, which is great to hear. I think the as code piece is really important as well, right? That ability to actually, there isn't a black box, there is actually things that are being created as code that actually let users as developers create this, as well as security engineers and others. In terms of your community, what split do you feel you have in terms of developers versus security engineers versus others?
We started with the entire focus on security first, like security practitioners first. The core reasons were like, we security engineers are the one who like spend a lot of time doing the assessment, designing the assessment, and we felt that products aren't designed for the end user experience of security engineers. So we kind of like really focused on them first. Like what are the key problems they face, how to really empower them, because we all were security engineers. We also had our own problems that we wanted to solve with the tools. So we really, really focused on security practitioners, like how to empower them. And that actually like really worked for us. And as you mentioned, like the piece of code, the programmability allowed different security practitioners to connect and also share their ideas and push how they can design their workflows better. And it really worked for us. In terms of our developers, we still, I won't say that we have really worked or like put entire focus on developers, but we are gradually working to ensure that developers have the right experience when using the tools. In terms of ratio, I would say like majority of our user base is security practitioners. We do have developers also using as well as contributing back, but it's actually led by security practitioners and then driven to the developers teams internally within the organizations or different teams.
Yeah, interesting. And do you see an ownership change, maybe more on pen testing side versus the DAST side, perhaps, of who is going to be running these types of, testing or tooling going forward?
Yes, and as I mentioned, the Nuclei framework was designed in a really flexible way, and our core idea was that over time we will consolidate all the different kind of security workflows within it. So if you are running as pen tester, you are working as red team engineer, you are working as DevOps, DevSecOps, you can use, or application security engineer, you can use Nuclei within your workflows. So our ultimate goal is like we would want to make sure that Nuclei works on all the different security teams within the organizations, whether you are ensuring around cloud, whether you are ensuring around audit or application. Nuclei can fit into those workflows and allow them to easily collaborate within the different teams. But yeah, over time, we are seeing as a more broader approach on using Nuclei.
Yeah, excellent. And how are companies using it today? You mentioned a couple of ways just there, but how are you noticing maybe large organizations or enterprises using that today in their testing?
It's pretty diverse. The one popular workflow is running or ensuring around attack surface mapping. So those who are working as application security engineers or managing the infra use Nuclei to write their templates, design their compliance, and run against those attack surfaces. But we also have pretty unusual varieties of uses by engineers working in enterprises. Some of them used for cloud, some of them used for infra security, many of them used for application, some of them used for the purely task approach. Some also use, and as I mentioned, like bug bounty programs management. So all the reports coming in, they provide the incentives on incoming reports, as well as they by default write the templates of all the incoming templates, even if researcher doesn't submit the template, and then use those templates to like put into different development pipelines. But yeah, because of this flexibility on writing your own templates, we have seen varieties of use cases, but majority of them use it for attack surface, infra, as well as application security.
And you mentioned in those templates as well that you can add remediation advice in, or remediation steps in those templates. Tell us a little bit more about that. And I'd love to kind of like understand how that kind of bridges the gap slightly between what perhaps developers are more used to in and around kind of like pen testing reports or DAST reports to actually help them fixing issues.
Yes. So there are two remediation workflows. One is when you can put out all the required information to how to fix the vulnerability. And the second piece is if you want to automate that workflow, you can define the action. Like you want to create a pull request for this version, you can put it into the template itself. And when a template executes, it will perform based on that. So let's say you have put out all the necessary information around the remediation. And if you triage that template, it will create a necessary ticket on whether it's Jira or any ticketing platform. And when developers try to fix it, they can either use the information to fix it or can use it, the automation that defined in the template to run. Either on those cases, once they've put out the fix or the remediation, they can rerun the template to see whether the vulnerability is actually fixed or not without needing to communicate with the security engineer again. So we like minimize the gap on doing the back and forth between security teams and developers, and developers can rerun to verify and push out the new status based on that.
Yeah, and I think that's really, really valuable. The fact that developers can actually run the tests themselves as well and actually validate that, you know, they are fixing, and they can even debug using those tests. It's just so different to how kind of like traditional pen testing is done today, where kind of the areas of trying to understand where an issue can be, you know, based on a pen test being run by someone potentially very, very far away. It's a very different space to try and understand and fix an issue.
Yeah, and also these black box rules do not give the technical context around the vulnerabilities. And with template, you can actually, like, because these developers are technical, they can really see what's actually happening behind the vulnerability. Like this action is being performed. They can really simulate that and can debug that easily versus like having that black box, just the data around the vulnerability without having the technical context behind the vulnerability.
Yeah, very interesting. So in terms of, you know, for you, I guess, in Project Discovery and also for Nuclei, what are the next steps? What are the things you're looking forward to doing in 2023?
There are so many things. We are, in terms of open source within the Nuclei, we are going to support a range of different workflows or security protocols. So users can expect to write different like varieties of new vulnerabilities using Nuclei. We are also very focused on supporting or pushing out new templates for different categories. So we have been focused mostly on application. Users can expect more templates in different categories too. Yeah, I think these are the two areas. And we are also going to push out this new program on top of our open source community. We are basically going to reward and incentivize for every contributions users make. The key reasons we are doing is that we have felt that we might not be able to scale our internal team to manage these varieties of public templates being contributed, because we have to triage them, we have to do the QA stuff, and then we merge back into our master branch. And we have felt that we are now getting overburdened with the amount of incoming pull requests coming from the community or new ideas coming from community. And that's why we are starting this program where users can actually get rewarded based on each of their contributions, like reviewing the templates, putting out the right content, validating the false positives. In each of these steps, they can be rewarded. The ultimate idea is that we can make Nuclei completely community driven versus like us running as a vendor driven.
Amazing. What a goal. That's a great goal to drive towards. Well, thanks very much, Rishi, for sharing that with us and our community. And where can people learn more about some of the tools and some of the ways in which you're building this?
The best place is GitHub. So username is called github.com/projectdiscovery. So project and discovery, like combine them, and we have all the tools listed there. And in each of the README for any tool you pick, you can see all the documentation or necessary information to get started.
Amazing. Well, thank you very much for joining us, Rishi. It's been a pleasure chatting with you.
Yeah, I really appreciate for inviting. Thank you.
A pleasure. And let's look forward to speaking to you all next time on The Secure Developer.
Thank you. Appreciate it. Looking forward.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecCon. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.